Chapter 13, The Chemistry of Wakefulness. For over 300 years, coffee drinkers knew it did something to them. It kept monks awake through the night. It made a goat herder's whole herd leap and dance. It sharpened talk in 1,000 coffee houses. Sultans and kings even feared what people said after a few cups. But knowing coffee did something is one thing. Knowing exactly what it did inside the body is another. That second problem took much longer to solve. A German chemist finds the culprit. The breakthrough came in 1820. German chemist Ferdinand Runge isolated the compound behind coffee's kick. He named it caffeine. The numbers show how potent it is. 6 pounds of coffee yielded only 90 grains of pure caffeine. That's a tiny amount from a big pile of beans. Runge called it a crystallizable salt with a bitter taste. It had an unusually high amount of nitrogen. Over 21% by weight. That's far more than most plant substances known at the time. He also noted something coffee drinkers could feel proud of. Just 4 or 5 grains of the pure compound gave the same lift as a good cup of coffee. The German chemist Justus von Liebig studied Runge's find. He concluded caffeine was nearly identical to theine. Theine was already known as the active stimulant in tea. It was an early hint of something big. Coffee and tea were about to spend 2 centuries competing for the world's attention. We'll cover that rivalry fully in the next chapter. 3 places caffeine goes to work. Once caffeine was isolated, researchers spent the next century studying it. They wanted to know exactly what it did in the body. Standard pharmaceutical references eventually settled on 3 areas. The first area matters most to this book. It's the central nervous system. Caffeine affects the parts of the brain tied to mental function. It produces wakefulness and sharper thinking. Sensory impressions get read more clearly. Thoughts move faster. At larger doses, the effect spreads further. It reaches the motor regions of the brain and nerves. A person can grow restless and noisy. At very high doses, it can even trigger convulsive movement. In short, the same effect that sharpened a monk's late-night prayers can, pushed too far, turn unpleasant. The second area is muscle, including the heart. Caffeine helps physical work. It raises how much a muscle can do before it tires. Researchers struggled to say how much of this came from the brain versus the muscle itself. Most evidence pointed to the brain suppressing fatigue, not the muscle. Caffeine also speeds up the pulse. It raises blood pressure slightly. But its long-term effect on the heart has a catch. Heavy, long-term use makes heart muscle more irritable. Over time, that adds fatigue to the very organ it first seems to energize. The third area is the kidneys. Here caffeine works as a strong diuretic. It raises urine output. It also changes what's in the urine. Less salt and urea, more total dissolved solids. Researchers even found a brief early effect. Caffeine first tightens the kidney's blood vessels. That briefly slows urine flow before the diuretic effect kicks in. This trait links caffeine to a small family of related compounds. One is theobromine, the main active compound in chocolate. Theobromine shares caffeine's effect on the kidneys. But it doesn't share caffeine's stimulating effect on the brain, putting caffeine through rigorous testing. By the early 1900s, researchers wanted more than descriptions. They designed rigorous experiments to measure caffeine's effects. One notable study used many test subjects. It kept both the subjects and the researchers unaware of the doses given. That's an early form of blind testing. Later, blind testing became standard across all of medicine. The study tested many things: motor speed, coordination, typing speed and errors, color naming, simple math, reaction time, even sleep quality and length. The results showed a clear pattern. Caffeine's effect on motor skills came fast but faded fast too. Its effect on higher mental work took longer to build but lasted much longer. Responses varied by person. Body weight mattered. So did whether there was food in the stomach. More than a century later, those are still the same reasons a cup of coffee hits 2 people differently. What the legends got right all along. Let's look back at where this book began. In Chapter 1 we told the story of a goat herder named Kaldi. His herd leapt and danced after eating berries from a strange shrub. We also told of a monk who boiled those berries into a drink. It kept his monastery awake all night for the first time. We noted, honestly, that historians see both stories as folklore, not fact. Now look at what this chapter just showed. The science lines up with the old folklore surprisingly well. Caffeine produces real wakefulness and sharper thinking. It helps physical activity and raises how much a muscle can do. In large enough doses, it can cause restlessness. It can even look like the leaping energy that supposedly hit Caldi's goats. The characters in these old legends were almost certainly invented over time. But the physical experience behind the stories was never fiction. Something in this plant really does produce sudden energy and wakefulness. 19th and 20th century chemistry simply explained, in careful lab terms, what people across 1,000 years and a dozen cultures had already discovered on their own. They found it through trial, error, and watching their own goats. An honest admission of what wasn't yet known. Let's end this chapter with some scientific humility. Researchers of this era were honest about what they didn't know. Even a century after Runge's discovery, one question stayed open. Did caffeine meaningfully change deeper tissue chemistry in the body's nitrogen processing? Researchers at the time called this, not distinctly answered. Their best guess was that caffeine's effect on general nutrition was neither strong nor direct. How the compound worked inside individual cells stayed unclear too. What made one dose stimulate the body more than another also stayed unclear. These were live questions, not settled facts. That kind of honest uncertainty deserves respect. By this point, careful science had mapped caffeine's broad effects well. It covered the mind, the muscles, the heart, the kidneys. And it still openly admitted the finer details weren't settled. That's a useful reminder. The science says, is rarely as simple or finished as people often make it sound. Taking the caffeine back out. Once caffeine was identified and mapped this well, someone was bound to try removing it. That effort succeeded commercially in Germany. Manufacturer Ludwig Roselius built and patented a real caffeine-free process. He sold it in Bremen, Germany for years. He brought it to America in 1909. The American product was first sold as Decafa. Then it became Decofa. In 1914, it finally became the name we remember, Coffee Hag. The industrial process was fairly involved. First, workers softened raw green beans with pressurized steam. Then they treated the beans with a chemical solvent. Common choices were benzol, chloroform, or alcohol. These solvents dissolve and pull out caffeine. Afterward, workers re-steamed the beans to drive the solvent back out. That left the caffeine in the extraction liquid, not the bean. Even so, chemists of the era admitted they could never remove every trace of caffeine. The best results still left between roughly 0.3 and 0.07% of the original caffeine in the decaffeinated bean. Nature had already solved this problem in its own strange way. French and German researchers found wild coffee trees on Madagascar and the nearby Comoro Islands. These trees had no caffeine at all. That's a genuine rarity within the same coffee genus covered in this book. For a while, scientists wondered if these were an entirely new plant genus. Closer studies showed they were simply unusual members of the genus Coffea. French botanist Professor Dubard gave them several formal scientific names. But there's a catch for anyone hoping this was nature's own decaf coffee. One researcher found these beans had no caffeine, but they did have a separate bitter compound, caffeine. By his own account, it made the brew essentially undrinkable. It's a fitting way to close this chapter. Even when nature handed the world a coffee plant with no stimulant, it made sure the coffee still wasn't worth drinking. What's coming next? This whole chapter showed one key fact. 19th century chemists saw caffeine and theine, coffee stimulant and tea stimulant, as nearly identical compounds. And yet, for centuries, whole nations and empires built strong loyalties around one drink or the other. Choosing coffee over tea or tea over coffee became close to a marker of national identity. In the next chapter, we'll look at that rivalry directly. Two drinks built on nearly the same active compound still ended up dividing the world. In more than one country's history, that choice became a matter of real political and economic weight.